everyone. This is Dr. M. Sendamir Selvi, Assistant Professor of Physics from SRM Madurai College for Engineering and Technology. In this video, I am going to give a short introduction to quantum computing and one of its gate, CNOT gate. Quantum computing is a field which uses principles of quantum mechanics to solve problems very faster than traditional computers. Any physical matters on its small scales, that is atomic scale, it exhibits properties of both particles and waves. This particular property is utilized by quantum computing for having specialized hardware. So quantum computer can perform calculations exponentially faster than any classical computers which we use conventionally. In conventional computing, classical bits are used for computation. Classical bits are the fundamental unit of classical information. A classical bit's state can take values either 0 or 1. Whereas in quantum computing, the basic unit of quantum information is stored in terms of quantum bits. It is also known as qubits shortly. A qubit state can take values both 0 and 1 at the same time, which is referred as superposition of states. These states 0 and 1 is to be pronounced at ket 0 and ket 1. The symbols are highlighted here in blue, which corresponds to the standard bracket nomenclature for quantum states. So the superposition of states, it means each qubit can be represented as a linear combination of ket 0 and ket 1, as represented here as state ket psi is equivalent to A times ket 0 and B times ket 1, where A and B are the probabilities of states ket 0 and ket 1 respectively. Single classical bit can take two different values, either 0 or 1. Only there are two possibilities. Two classical bit can take four different values, that is 0, 0, 0, 1, 1, 0 and 1, 1. So there are four possibilities of two classical bit. On the other hand, in qubits, let's see single qubit has to be represented by a state ket psi is equal to the combination of both ket 0 and ket 1 in terms of the probabilities A and B as denoted here. And similarly, 2 qubit can be represented by combinations of four different values, that is ket psi is equal to A times ket 0, 0 plus B times ket 0, 1 plus C times ket 1, 0 plus D times ket 0, 1. This picture shows the classical bit is represented either by 0 or 1, that's denoted by a coin, either white side on the top or the black side on the top. Two different possibilities. Whereas in quantum bit, the same coin is not aligned up or not down exactly. It is aligned somewhere in between the two states. So all the combinations of different orientations can be represented by a qubit representation. So the term entanglement means the different possibilities listed here can anytime depend on each other. That is known as entanglement. This picture represents the two-state quantum system used in quantum computing. To understand the location of a particle lying somewhere across x, y, z in a sphere, it is to be represented by the combination of both 0 and 1, which is known as superposition of qubits. The advantage of using quantum computing is it can perform parallel arithmetic operations. It can do exponential multiplications per qubit, and lot amount of data can be handled in a given possible time. Let's see what is CNOT gate. There are classical logic gates like AND, OR, NOT, NAND, NOR, etc. These gates take certain input signals and gives the corresponding output signals according to certain rules assigned. This CNOT gate is one of the fundamental quantum gate used in quantum computing. It uses 2 qubits, which is also known as controlled NOT gate, as it does NOT operation, also known as bit flip. As mentioned earlier, CNOT gate uses 2 qubits. The first qubit corresponds to control qubit. The second qubit corresponds to target qubit, which means the control qubit value takes state 0 or 1. Whenever control qubit take values get 0, the target qubit value remains same on the output. Whenever control qubit value takes 1, the target qubit value shift from 0 to 1 or 1 to 0. There are 4 combinations of inputs as CNOT gate works on 2 qubits. So the first 2 cases highlighted in blue shows control qubit is 0. So the target qubit, if it is 0, it remains in 0. If it is 1, it remains in 1 without any change. The other 2 cases, the control bit is 1. So the target qubit 0 changes to 1 and the target qubit 1 changes to 0 in the last 2 cases. So the CNOT gate flips the state of the target qubit if the control qubit is in state 1. The truth table of CNOT gate and the symbolic representation of CNOT gate is presented here. So on the truth table, the input is given for control qubit X and target qubit Y. On the output, control qubit has the same value as the input, whereas the target qubit remains same or it flips depending upon the control qubit. So when the control qubit is 0, the target qubit remains the same. When the control qubit is 1, the target qubit flips from 0 to 1 or 1 to 0. To summarize this video, using classical computing, the outcome can be either on or off, that is 1 or 0. Whereas quantum computing using qubits can able to give infinite amount of outcomes simultaneously at the same time. Check out these references for more understanding on quantum computing. Thank you.